Assalamu alaikum, children. I'm just explaining further about the curved mirrors. Actually, the curved mirrors we saw in our earlier video also. The spoon, the metal spoon. The metal spoons, the concave inverse, the curved inward. The curve which is inward we called as concave surface. Okay, that concave surface is acting as a concave mirror. Here the spoons, the outer side which is curved outward, we called as convex surface. That's what the metal spoon also, it's acting as a mirror and forming some images. Okay, now here see, this is called as, we denoting the concave mirror like this, a curved line, like eyelashes symbol, eyelashes, like we have to put outward. So the reflecting surface is, this is the reflecting surface. This is the convex mirror's reflecting surface is outwards. Okay, here concave mirror's reflecting surface is inward. So concave mirror's reflecting surface is outward. This is the reflecting surface of convex mirror. Hope you got it. And also, I'm just explaining to you, which is not in your book, the curved mirrors we called as spherical mirrors too. Okay, spherical mirror. What do you mean by sphere? What do you mean by sphere? Sphere means, a 3D golakara. A figure we called as sphere. Okay, spherical mirrors means there is a sphere which is used as a mercury cover. So it has cut like this, the spherical shape, spherical glass ball. If you cut a piece of this, and if you apply the mercury on it, we can use as a concave mirror. Okay, so the spherical surface, which is, if it's cut by this place, and if they apply the mercury on it, inside of it, and the reflecting surface will be acting as outside. So this is a convex mirror. This is a concave mirror. Got it now? How do they prepare the, or else making the curved mirrors? Concave mirror also has a center. Okay, center, because it's a spherical mirror center. So this center will be marked as C, and its convergent point always half of the center and the pole. This is called the pole. This is called the axis. So this will be its focal point. Okay, exactly half of this. CF is half of CP. Okay, now likewise only, the lights are reflecting here. So in this place, there is also a center point of this. So this one is C and this one is the focal F, but always the parallel light beam is as if coming from F, it will be spread out. Okay, as if coming from F, it will be spread out. Okay, this is on if you direct a parallel beam of light, always the parallel beam, if it goes through the axis, it will be coming back as it is, because it's it falls perpendicular to the surface, the reflecting surface. So because of that, it's coming back, and the others will be reflecting as it comes from F, it's spreading out. Here, if there is a parallel light beam falls on the reflecting surface, it will be converge to the spot, to a spot. Like here in the axis only, here is also, if there is a light ray falling on the, the on same as axis, it will be perpendicular to the reflecting surface. So it will be coming, reflecting back. Okay, now keep it in your mind. The curved mirrors also called as spherical mirrors. The spherical mirrors I have explained now how do they make. Now you can get an idea now. There will be a center for that, and the focal point which is collecting to the spot or as spreading out from the spot, which is called as F. Okay, and the center point we call the C. This is the axis. Always the rays on the axis will be reflecting back, and the other the other reflection, the parallel reflection, will see clearly. 1 minute. Now children, this is a concave mirror. This is what? A concave mirror. So concave mirror, this one is the axis, we'll say this through this axis. This one is P, this one is the axis. Now, if there is a parallel light beam is falling on the reflecting surface of the concave mirror, it will be collecting to a spot, towards a spot. Okay, how it's, this is the parallel beam of light. It will be collecting towards a spot of, now the axis will be reflecting back as it is. The other rays will be collecting towards a, so this one will be the focal length of the, or else the focal point of this concave mirror. So this is called the convergence of light. This is called the convergence of light because it's collecting to a spot. Okay, now we'll see the convex mirror. This is concave mirror now. This is concave mirror, and this one is convex mirror. In convex mirror too, there will be a axis. This one is P. So this one is P, and actually its C is here, somewhere around here, and its F is here. Okay. Now, when there is a parallel light beam is falling on the reflecting surface of the convex mirror, what will happen? If the parallel light beams, the light ray which goes through the axis will be reflecting back as it is because it's perpendicular to the reflecting surface, and the other rays will be reflecting back as it's coming, spreading out as it coming back from the focal point F of its F. It's reflecting back. It's reflecting back like that. This ray will be reflecting back like that. This ray will be reflecting back like this. as it is, and this one will be reflecting back, and this one will be reflecting back, and this one will be reflecting back. So it's called divergence of light. Divergence of light. Okay, this is convergent of light. It's collecting to a certain point. This is divergent of light. It's spreading out the light rays, a parallel light ray. Okay, now this mirror has another name also. Another name is what? Concave mirrors, another name is convergent mirror. Okay. Because it's converging, the light rays. Here, divergent mirror. Okay. Now, hope you understood the the reflecting way of in concave surface and the convex surface. Okay. Now, go through my video and study what are the instances we are using. We using the concave mirrors. What is the instances we use? Okay, the dentists are usually using in their dentistry, and the people they're using for shaving purposes. And what else? In the solar cooker they're using. Now, for an example, solar cooker. This concave mirror, if it's used like this, okay, in the flat surface, the solar cooker is like this only. Okay, there will be some handles. So this is how you are keeping the pot or pan or something. Okay, to heat the whatever the material. Okay. Now, what will happen? The sun rays will be falling on it parallelly. The sun rays will be reflecting back. So as it reflects to the pot directly only, they have calculated, the focal length and have made the solar cooker like this. Now you understood the parallel light beam will be fall on the concave surface and will be reflecting back to a spot. Okay, towards a spot. So this spot will be getting heated by the solar heat. Got it, children? So in solar cookers for shaving purpose, and in solar cooker, and in the microscope, okay, to direct the sunlight towards the stage to see the specimen well. So those are the instances we are using the concave mirrors. And convex mirrors, what are the instances we are using? Convex mirrors, always we are using the convex mirror in the side mirrors of the vehicle. Okay, side mirrors of the vehicle. You write properly. And also, children, always the images formed by the convex mirror is small and upright. Here, in different focal length, in F, in C, and further beyond C. So if it's the image is kept near the reflecting surface, the image will be bigger than the object and upright. Because of that only, the dentist and the shaving purposes, it can be used to enlarge the image, enlarge the size of the image. Okay, so if it's kept in F, it's bigger than the object and upright. Okay, the image. So if it's kept in C, it will be same size of the object. If it's beyond the C, further, apart from C. It's the smaller than the object. Likewise, in concave mirror, according to the different length, the image also formed differently. And here, convex mirror, always the small image, smaller than the object, and smaller than the object, and upright images will be formed. Okay, have to keep it in your mind, and just try while you are doing answering the questions to my questions, and just practice how you are converging the light beam and diverging the light beam, so may come for the exam inshallah. Okay, okay children, assalamu alaikum.